Today, we're going to follow the amazing journey of a single, tiny piece of tech. We're going to see how an idea that starts in someone's basement can literally scale up to change a multi-billion-dollar global industry.
So it sounds kind of like a riddle, right? You've got this humble little home gadget on one hand and this massive economic sector on the other. The connection between them isn't obvious at all, but, it's an incredibly powerful one, and it tells us a lot about how innovation really works today.
And the secret ingredient, the thing that ties it all together, is this little guy right here, the ESP32. It's a microcontroller, which is basically a tiny computer that acts as the brain for, well, countless devices, connecting our physical world to the digital one.
So what is this thing exactly? Well, the best way to think about it is like a programmable Lego brick for electronics. It's super cheap, it's surprisingly powerful, and this is the kicker, it comes with Wi-Fi and Bluetooth built right in. That makes it the perfect tool for connecting just about anything you can imagine to the internet.
And that accessibility, that's really where our story kicks off. We're starting at the smallest possible scale, taking a look at how everyday creators and hobbyists are using these little chips to solve real, practical problems around their own homes.
Okay, check this out. We've got this example from a Reddit user, LabThink. They wanted their ventilation fan to just turn on by itself when someone's in the shower. So, using a simple temperature sensor on the hot water pipe, the ESP32 knows exactly when to kick the fan on. I mean, it's a simple, super elegant solution to a common little annoyance.
But it's not just about simple convenience. LabThink also had a plan to tackle a damp crawl space. So by sticking some sensors down there, the ESP32 can collect data on temperature and moisture over time. Now this isn't just a gadget anymore, it's a diagnostic tool. The data is what proves whether their fix is actually working.
And this is where it gets really smart. By keeping an eye on their home's solar power output, the ESP32 can actually tell the heat pump when there's extra energy to burn. It's creating a tiny, personal smart grid that makes their energy use way more efficient. These aren't just toys, they're seriously powerful tools for automation and data collection.
All right, let's move on to the next stage and see how this all builds up. Because, having a great idea is one thing, but making it work reliably, that's a completely different challenge. And that's where the engineering grind really comes in.
Yeah, even with a component as awesome as the ESP32, you can't just throw things together and expect it all to work perfectly. You're dealing with real-world physics and electronics here.
Okay, what's really cool about this slide is how it breaks down a classic hardware problem. According to Espressif, the company that actually makes the chip, you might have a device that can send out a signal just fine. That's the transmit part, but it's terrible at receiving one. This is usually caused by signal interference, where other electronic bits on the board are basically screaming over the signal you're trying to listen to.
And the solution? Well, it's not magic. It's just good, smart design. You have to isolate the antenna from all the noisy parts. You reroute wires so they don't mess with each other, and you shield the really sensitive radio components. This is the nitty-gritty work that turns a hobbyist prototype into a stable, reliable product.
Okay, so we've seen the individual creator and the engineering challenges. Now, let's zoom all the way out and see what happens when this exact same core idea gets picked up at the corporate level. A huge company like OKI isn't just thinking about one device in one house. They're thinking about a fully integrated, connected world. Their entire strategy is built around these three pillars: connecting society, connecting lifestyles, and connecting manufacturing. It's the same fundamental idea, linking the physical and digital, just on an absolutely massive scale.
So let's just focus on that first one, connected society. The key concept here is something they call smart sensing. Sound familiar? It should. It's exactly what our Reddit hobbyist was doing, using sensors to gather data and then act on it. But now it's being applied to things like public infrastructure. So instead of a little temperature sensor on a pipe, Oki is using advanced fiber optic sensors embedded deep inside a bridge. These things can detect tiny, microscopic changes in temperature or physical stress in real time. They're basically monitoring the bridge's health 24/7 to help keep people safe. And this slide just nails the whole concept. On the left, you've got the hobbyist measuring moisture in their little crawl space. And on the right, Okai is using the exact same principle, smart sensing, to manage temperature across an entire massive factory floor. It's the same idea, just scaled up by a factor of, I don't know, 1,000,000.
And now for the climax. This is where it gets really wild. We've seen the idea go from a basement project to a corporate vision. But where is this tech creating the most tangible, world-changing value right now? The answer might surprise you. It's on the farm.
Get a load of this number, $54.71 billion. That is the projected size of the smart agriculture market by the year 2030. We're not talking about some niche market here. This is a massive economic revolution, and it's all powered by this connected tech. And just look at that growth. I mean, the market is set to more than double in just 6 years. This kind of explosive demand is being driven by a very real need to produce more food, more efficiently, and hopefully more sustainably. So what's actually driving all this spending? Hardware. A full 2/3 of the money is going to the physical devices, the sensors, the control systems, the drones. These are the modern-day tools of farming, the real-world application of smart sensing on a massive scale.
And this isn't science fiction. This stuff is happening right now, as we speak. Drones are flying over fields, monitoring crop health. Driverless tractors are plowing those fields. And sensors, just like the ones in that crawl space, are monitoring soil moisture to optimize every last drop of water. Every single one of these innovations relies on that core idea of a small, connected computer.
So after all that, what's the big takeaway from this incredible journey? Let's try and boil it all down.
We've basically followed an idea from its simplest form all the way to its most impactful. It all starts with one person solving one small problem. Then an engineer has to refine the tech to make it reliable. Then a corporation applies that tech at a huge infrastructural scale. And finally, that scaled-up solution creates a global market that fundamentally changes how we feed the entire planet.
And the most crucial point here is that this whole thing started with a simple, accessible building block. That Lego brick that empowers literally anyone to connect the world around them has already transformed our homes and our farms. So the question is, what's next? What other essential part of our world is just waiting to be connected?